Good morning. Is there any problem? Morning. Can you see the worksheet? I can see it here upside down on the screen. Yes, okay. So we're going to solve this worksheet. It's basically about the last topic we had about sequences. So here the first assignment asks you to evaluate the first n elements. So if you start at 0, then you need to evaluate A0 up to A5. So this is the first assignment. So evaluating the terms of a given sequence. And here we have different definitions of the sequence. Some are given as what we called explicitly, so directly, and others using recursive formula, meaning that you need to use the previous terms to evaluate the next terms. And so here first 6 terms means A0, A1, A2, A3, A4, A. Okay, so for each sequence, notice that the second one is this the sum of all the previous. It means you start at 1. The number C is we studied actually the factorial. Number D is interesting because it's using recursive. That means first element is given, second is given. Of course, here you need to evaluate A1 up to A6. So you evaluate the terms starting at A3 using the previous term. So 3 times the previous one next to the left, and then the previous to the previous. Okay, so this one, these two actually straightforward. So it's A sub n equals A0 times, plus n times D. Here A n equals A0 Q to the power n. So all you need to do is to place them. Okay, any question regarding the first 3 assignments here? Oh, someone is waiting. Guys, are you solving? Do you have any difficulties with the first three assignments? So no response means everything okay? Anyway, just write on the note if you have any problem. So, so if you want to compare the answers, here is the answer for question 1A and B. Zoom it out a little bit. Okay, so basically you just uh, start with 0 if possible. In some cases, if the sequence starts at 1, it's not possible. So just plug in 0 for n, 1 for n, 2 for n, 3 and 4 and 5, and you got these values. Now the second one, it says the first element is 1, and then the next elements you just sum the previous elements, all the previous elements. So the first element is 1, the second element is the sum of all previous elements, so it's 1 plus nothing, it's 1. And then starting there, you just add all previous elements. So here you add, for instance, A3, you add 1 and 1, you get 2. For A4, you add all the previous elements, 1, 1, 2, 4, and so on. So this is the meaning of this sum symbol. It's an is all elements up to an minus 1. That means it's all elements to the left of the current element are added up and you have the right value. Okay, got it, right? Okay, now number C here is interesting. This type of sequences, we will talk about them when we come back from the holidays and talk about increasing and decreasing. So if you consider such sequences, you see this number here, the 5, it's an exponential function. And here in the denominator, you have a factorial. Now, the thing is that factorials at the beginning, they don't increase rapidly. However, when you proceed, it becomes very, very large numbers. And it's the opposite with the exponents here. So this ratio here, let's check it. So at the beginning, you have 1, then 5, then 25 over 2, which is 12.5. So as you see here, it is increasing. And then this one is 20, I don't know, maybe it's about 30, right? So it's increasing. So this one is about 12.5, this one about 20 something, 20 point something, so 26. So you see here, A4 and A5 are equal. So that's why I evaluated it using the decimal here, so that you compare them. From there, we will see it will start decreasing. That means here you will be getting something below 26. And it's actually, this pattern is always true. So for here, instance here, if you have, let's say 9 to the power n over n factorial. So it will increase up to 9 minus 1, which is 8. And 9, it will be constant and it will be decreasing. So we'll see later, this will be just converging to 0 at the end. And later we'll see that most of the theorems concerning the behavior of the sequence, whether it's increasing or decreasing or whatever, it does not require that. This is important theorem. It does not require that the function or the sequence is increasing or decreasing for all values. So all these theorems, you will be having the term for all but some, or for almost all. That means it's no problem if it's increasing, like here for 4 or 5 terms, then it starts decreasing. Still, it will be converging. But this we leave it for next year. Okay, number D is also interesting. So I tried here in this assignment here, this exercise, to bring all the different possible, let's say, scenarios for defining a sequence. So in this case, this is what we call the recursive definition of sequence, where you basically just evaluate the terms using the previous terms. Okay, so if you attended the lecture yesterday, for instance, we had defined the Fibonacci numbers in this way. So this one, it says that A1 is given, A2 is given, starting A3. Starting A3, you have this formula 3. Notice that uh, an an minus 1, an minus 2. An minus 1 means it's the previous term immediately, and an minus 2, it's the previous of the previous. Okay, so here you need just to multiply the previous term with 3, and then the one that is previous of the previous term by 2, and subtract them, and you are there. Okay, for instance, here to evaluate A3, in this case, an minus 1 is A2. So 3 times A2 is 9, and then you subtract 2 times A1, which is 4. So you end up of having 5, and so on. Is it clear? Okay, so this is a typical recursively defined sequence. Okay, as I told you, I just tried to include all different noisy here. Okay, so I tried to include all different, let's say, possible ways to define sequences. One of them is using the recursive and the sum, etc. But sometimes the sequence can be split into 2 or 3 or whatever. So this is what we call this definition, a piecewise defined function, where the function is defined for let's say in this case odd or even. So it does not have an entire, let's say, definition for all. Nevertheless, you need to identify the value and then plug it into the corresponding value. I hope that all of you know that this one is okay. A0, 0 is odd or even? Zero is, guys online, 0, is it odd or even? I've seen exams that many students mix this up. So Sabrina, are you there? Tahiri, Abdo. No idea. 0 is even or odd? Don't know. They're not responding. Both. Oh, 0 is both? No, it's either or, yeah? 0 is even, right? 0 is even, odd, and so on. Okay? 0 is even. 0, 2, 4, 8, 4, 6, 8, 10, and so on are even. Then you will be plugging in according to the formula here. So if, for instance, here, if it's odd, then it's 3 times the number. So for instance, 1 is odd. So at 1, A1 is 3 times 1. A3 is 3 times 3, and so on. But if it's even, it's 1 over n plus 1. So at 0, it's 1 over 1 plus 0. At 2, it's 1 plus 2 plus 1, and so on. So that's why you will be getting these values here for number number E. All right. So please, if you have any questions regarding this first. So it's just straightforward. You need to plug in the values. And as I told you, the thing is here, if you start with A0, as you see here, for instance, um, the question number D, we started at 1. A0 is not defined. And sometimes you can start at 0. And you need to be careful to the formula. So for instance, in the question number 2, question number 2 is actually, sorry, straightforward. It is very simple. But why do we need the general term? Now here, before I start, many of you maybe saw this in literature, or they know the formula. Usually, if you start at A0, then this is the formula. AN equals A0 plus N times D. So here you have A0, which is the first element. So A0 here refers to the first element, plus N times D. If you start at 1, it's N minus 1 times D. This is important, okay? And the second one, it is also given A0 and D. So usually the arithmetic sequence, you have a constant. If you subtract the two successive terms, you have a same constant, okay? For instance, 2, 4, 6, etc. So it's always 2, the difference between any successive terms, what we call D, okay? So here, first element and the constant that is the difference, or difference between two successive terms. In arithmetic sequences, however, again here, if we have start at A0, it's A0 times Q to the power N. If we start at A1, it's A1 times Q to the power N minus 1, okay? So here, first element, then Q to the power N. First element, Q to the power N. Why is this general term important? Because it allows us to evaluate any position, right? So for instance, here, if I want to evaluate the 100th term of this one here. So all I need to do here is just plug in here 100 for N. So I have 300 minus 1, which is 290, right? No, 900. 900. No, 300 minus 1, which is 299, for instance. If I want, for instance, the 50th term of this one, I will just multiply 2 with 1 minus 50, which is negative 49. So I got negative 98. Okay, so this is how we use the general term. It allows us to evaluate the value of any unknown position of the sequence. Clear? Now, uh, if you have this is maybe important for the exam. Let me just give you here some insight of that. So if you are given a sequence, and then you are asked to evaluate the sequence, let's say, I don't know, let me just give you something like let's say -4 -2 0 2. Okay, first of all, is this sequence an arithmetic or a geometric sequence? How would you decide? What do? You go and compare the elements. Compare the elements here. Obviously, these two elements are If you subtract this one from that one, you will be getting 2, right? 2 or minus 2 here? Minus 2 minus 4, right? So it's 2. 0 minus, it's 2, okay? So here you get 2, here you get 2. So that means this constant D is the difference between, if it's constant, if it's the same difference, then it is arithmetic sequence. So this is D, this is your first element, then you will say AN here is equal to first element negative 4 plus N times D, in this case D is 2. Okay, so this is how to find out the general term of a sequence if you are given the numbers. Okay, now if you, this in this case here is the arithmetic sequence. Okay, so arithmetic sequence, you need to find out D, which is the constant between two successive terms and the first element. Now the geometric sequence, we need Q and first element, right? But what is Q? First element usually is given, it's first element of the sequence. But what is Q? For instance, uh, let me take this simple one. 10, 100, 1000, 10,000, and so on. Okay. Now, what is Q? Q is defined for this sequence is AN plus 1 over AN, or you can say it's AN over AN minus 1. So it means it's the quotient of dividing two successive terms. Let's take the first term here. So 100 over 10, 10, 1000 over 100 is 10, and so on. So here this is Q. Okay, how to evaluate Q? You divide two successive terms and you get Q. Now you know this is the first element. So AN here is equal just to 10, first element, multiplied by Q. In this case, Q is another 10 to the power N. Okay? You can say it's 10 to the power N plus 1 ultimately. Is that clear how to read from the sequence N and Q? Now, if you are asked here after you evaluated, for instance, this one, if you want to evaluate the element number 60, then you just plug in here 60 for N negative 4. This is the meaning of general term. You can evaluate the value at any given position. Okay, question number 4. As I told you, limit approaching infinity. If you have two polynomials with different degrees, equal degrees, or one is greater than the other, you just always divide by the highest term. Divide by the highest term here, okay? And then you will simplify, and always, if you have here the denominator is greater, then it goes to 0. So for instance, this one here, this one, if we divide here these, we will get 1. Here we get also 1. This will go to 0 and so on. So here we divided everything. The same here, we can apply it. Actually here I just simplified it to get the 2. But here you see that 2n plus 1 is just a polynomial. You can divide everything by n and you get the same result here. Here we have two polynomials with same degree. We end up of having these two coefficients 1 over 1. Here we have the numerator have less degree than the denominator, so we divide everything by n to the power 3. So here we get 1, all others go to 0, so we get 0 over 1, and it's ultimately 0. So if you have a polynomial, we have the 3 cases that we had in the class. If you didn't join the class yesterday, we will explain it later today. And okay, before we go to the break, the interest rate formula is actually the simple rate follows the arithmetic sequence, and the compound rate follows the geometric sequence. So you start with the amount. So it's this is the notice that here is an is the value of the account after n years. Okay, and this is given by, so first of all, what is D here? D is the profit of the interest after 1 year. Okay, so it's just like the amount multiplied by the rate, the interest rate, and don't forget to transfer the interest rate into decimal. So for instance, if you invest here 5,000 euros at 3% for 1 year, then you will be getting at the end of the year 150 euros. After 2 years, it comes another 150, and so on. So that's why after 5 years, you will be having here 5 times D added to the principal or the starting capital, and you get the amount of the account after 5 years. So A5 is meant here. Same here, in if you use the geometric sequence, then your Q is 1 plus the 1 plus the percentage, or the percentage in decimal. Of course, in this case it's 103, and then you have 5,000 multiplied by 103 to the power 5, and it definitely is a little bit more, because this one, after 1 year, you have 150. So in the second year, the interest will be given not for 5,000, for 5,000 plus 100, 5,150. And the third year, the interest will be added. That's why it's called a compound interest rate. Okay. So I will be uploading the different. So let me just go to Island. It's actually there. Let me see. Yes, it's online, so no need to write it. I will just make it visible. Okay, so solutions for worksheet number 9 are already online. So this one is online. Just please compare them and let me know if you have any problem. Don't worry about this triangle at the end. It's just this one. It's meaningless. Okay, so maybe you saw the announcement for next Wednesday. We're going to have the mock exam at 8:30. It will include everything up to worksheet number 9. And please take it seriously, prepare well, and try to uh, assess yourself to see what deficiencies you might be having to make it better for the real exam. Okay. Questions? You have any question? Yes, please go ahead. Worksheet number 8. Just hold on. Solutions worksheet number 8. It's in the on the first page. It wasn't in sequence. Yeah, yeah, it's on the first page. No, no problem, no problem. I didn't put it in a row. It's on the first page. It's on the first page. Okay, you just check it and let me know if you need anything. So, gibt es Vorlesung hier? Also 7 ist gut. 07. 010, okay. 010 ist gut. Danke. Ja, super. Danke. Danke. Okay, so the equation, but you understand the concept, yeah? Because we don't have division, you need to evaluate the inverse, but be careful, multiplying from the right is different than multiplying from the left, okay? Yeah, 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 but it's there on. But you are right, it's not in a sequence, so I didn't put him one, two, three, four. Okay, so any other questions? Okay, so All right. Can you hear me now? Should be fixed the problem. Can you hear me? Hmm, what is the problem here? Lautsprecher. Lautsprecher microphone is media part. Okay, guys, you should be in the position to hear me, right? I have no problem here with the device, I assume.
Yes, Professor, we can hear you.
I can't hear anything. Let me just try. Someone was saying anything. I couldn't hear you. Okay, great, great. You can hear me. Okay, so today we will, uh, just 1 second. Okay, today we're going to start a new chapter actually. But for the mock exam on Wednesday, some students are asking about the mock exam. I bet these students don't check regularly the announcements. I posted something on Island. Actually, it will be on Wednesday, next Wednesday. We're going to start the exam sharp 8:30, so we need a couple of minutes to fix the exam. So please be there about 15 minutes earlier. Okay, so it will include everything up to the topic that we covered this morning, which we will just repeat it now for those who didn't get the class yesterday. Okay, sequences. What are sequences? Now, you all know social media, you are always getting some quizzes, right? Like, I don't know, you can see it clearly, the projector here? Can you see it clearly or need to be zoomed? Light? You can see it clear? Okay, so if I give you the sequence, let's say 3, 6, 9. I hope you can see it. What would you predict the next number will be? What would you expect next? No idea?
Well,
Now someone is saying something, but I'm sorry, I don't know. There's problem here with the setup of the microphones and maybe the speakers. Can you write it on the chat, please? Very simple sequence. Of course, you expect 12 here, right? You expect 12 and so on. Now, if I ask you, how did you guess that it's 12? You will most probably tell me that you looked at the previous terms and you figured out there's a pattern. There's a pattern, which is what we call the general term. So obviously here, this is the first element, and then from there you just add 3 to get the next term. Okay, add 3 to the previous term. So here the next one will be plus 3, 15, and so on. Of course, of course, there are other little bit more complicated. And I saw also I used to be getting some quizzes on social media, like if this sequence they give you 3 4 numbers and then tell you what would be next. But of course, most of these are not clearly defined or ambiguous or whatever. So obviously, it could be more complicated, the pattern or the general term, or harder to find. Okay, now in this chapter, chapter 3, we will talk about sequences and series. We will define in short. Now, what is a sequence? You just had an example. It's, if you like, a set of numbers. Of course, we learned that sets are, in general, sets are not, they are not, how you call it, they are not directed, so they don't have the direction or the ordered. Yeah, maybe ordered is the right word. They are not ordered. That means that whether you write the first element at the beginning or the end, it doesn't matter for a set. But here it's important that this one is an ordered set, and this is what we call, it's ordered set, and it's always also infinite. So you have an infinite number. So usually a sequence is, we will see in short, can be looked at as a mapping between the natural numbers or the non-negative numbers, integers, and the real numbers. So we will see the exact definition of that. But for now, let me just uh, um, okay, that's it. Okay, so a sequence and a series. So this is the title. So a sequence, you can look at it as I said, an ordered it's an ordered list of numbers. Okay, so this is the definition of this. And the numbers are called